Good day, viewers all over the world. I welcome you to class today. We shall be continuing with our topic, coordinate geometry. In our last class, we looked at coordinate geometry part 1. Today, we shall be looking at coordinate geometry part 2. I hope you had a better understanding of what the introductory part of coordinate geometry is all about. Thank you for watching the video. For those of you who have subscribed to my channel, I want to thank you for subscribing to my channel. Thank you for sharing my videos across all social media platforms. I'm very grateful for that. For those of you who are yet to subscribe, please subscribe to my channel. My name is Dr. Chris Esekaibe. I'm the owner of this YouTube channel. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I am also a member of the academic board of that same polytechnic. By the special grace of God, I have more than 18 years of lecturing experience in universities, in polytechnics, and also in advanced colleges here in Nigeria. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I'm a specialist in numerical analysis, data analysis and modeling, and statistical analysis. If you are an AI firm, you need mathematicians to help you train your AI models. Why not? You can contact me. I've worked with 2 renowned firms in the United States of America, AI firms. I assisted in training their AI models. Why not? If you're an AI model, you can contact me. I can create prompts that will help stomp your models or break the models, and I will now create rubrics and golden responses for training the model. I can also provide chain of thoughts for also training the models with your team of mathematicians. Peradventure also you are a research institute, you can consult me and let me be part of what your research team is doing, especially in the area of statistical research and mathematical research. And also, if you are a postgraduate student or a student, you need clarity in any area in numerical analysis, you can also consult me. I have had people consulted me from Malawi, from Uganda, and other parts of the world. I'll be looking forward to hearing from you. My contacts are +234, this is the Nigerian code, +234 then 8033021903. This first number is for call and WhatsApp. Then the second number is for call only, +234 7066297535. And of course, my email is chrisdavids2015@gmail.com. I'll be looking forward to hearing from you. And please, if you have not subscribed, please do that as you are watching this video, and God will bless you. Click on the notification button, and so that anytime I upload a new video, you will be among those that will get a notification. Share my videos in your social media platforms, like the videos, and as you do, God will bless you. The essence of this YouTube channel is to share knowledge in key topics in mathematics and statistics across the globe. So if you are sharing the videos, it means that you are part of those sharing knowledge in these areas across the globe. God bless you richly. Now, permit me to go to the subject of the day. We are looking at coordinate geometry part 2. Today we shall be looking at intersecting lines. We shall be saying how we can calculate the area of a triangle or the area of any given quadrilateral using the vertices of the triangle or the quadrilateral. You know, a vertex is a point, and the point has 2 coordinates, the x coordinate and the y coordinate. The x coordinate is called the abscissa, while the y coordinate is called the ordinate. So we are looking at intersecting lines first of all before we go into that, and of course we shall be looking at collinear points also. When are 3 points said to be collinear? We are going to be looking at that in this particular class. So please wait patiently, watch the video patiently to the end, and as you do, God will bless you richly. Now, intersecting lines. In the situation when two lines intersect, for instance, if I have one line like this and another line like this, you can call this point A. This is a point here. A may be having, you can call this point A. This is line 1, this is line 2, and they have intersected at point A. And of course, line 1, the other time we gave you the equation of a line. The equation of a line is given as y equals mx plus c. M is the gradient, yc is the intercept. So from the two lines, we are to, at the point of intersection, we are to solve the equations of the two lines simultaneously so that we can get the particular point where the two lines intersect. So when we talk about the intersection of two lines, we are talking about getting the coordinates of the point where the two lines intersect. And of course, the values that we are going to get as the coordinate, of course, we'll get the x coordinate, which is the abscissa, and the y coordinate, which is the ordinate. It must satisfy the two equations simultaneously. The two equations, of course, every line has an equation which is in that format. Now, for instance, let us take an example. Let's take an example. You know, in mathematics, you solve problems you explain them better by solving a particular example. If I call this example, find the point of intersection. Find the point of intersection. The point of intersection of the lines. The first line is 2x minus y equals 3. And the second one is x plus y equals 6. So we have to find the point of intersection, just the way I explained it. Now, what we need to do, like as I explained earlier, we have to solve these two. This is a line. This is also another line. This is the equation of a line, of the first line. This is also the equation of the second line. And you can see these are linear equations, and of course, the lines are straight lines. So we can go ahead using elimination method. We can now solve. You have here 2x minus y equals 3. Then the second one is x plus y equals 6. So we want to use the elimination method to eliminate one of the variables. You can see the coefficient of y here is minus 1. The coefficient of y here is plus 1. So we can go ahead and eliminate. We can now add the two equations and eliminate y. So now, if we say minus y plus y, of course, we will have 0 here. So the variable y is eliminated. Then 2x plus x, this will be 3x. Of course, we put a plus sign there. Then 3 plus 6 is 9. So this implies that x will be equal to 9 over 3, and that will be 3. That's what you have. So from any of these two equations or any of the two lines, you can get the value of y. Of course, from this one, from x plus y equals to 6, we can get, since x is 3, we have 3 plus y is equal to 6, y equals 6 minus 3, and that is 3. So you can see from what we have solved, our x is equal to 3 and our y is equal to 3. So the point of intersection x comma y is up will now be 3 comma 3. So you can see that the abscissa is 3 and the ordinate is 3. So that is the point of intersection for these two lines. That is how we have been able to solve that. Now let us take another example and see how we can explain this further, still on intersecting lines. I hope this particular example is clear enough. Permit me to clean the board so that we can take another set of example. This one we also explain how to calculate the coordinates of that point where the lines intersect. Now this one is another example. This one says find the coordinates of the vertices. Find the coordinates. Find the coordinates of the vertices. Find the coordinates of the vertices of the triangle formed by the lines. Now, formed by the lines, of course, our L1, which is the first line, our L1 is 2x plus 3y is equal to 5. 2x plus 3y equal to 5. Then our L2, of course, a triangle has 3 lines. So L2 will be the second line. L2 will be 3x minus y equals 2. L2 is 3x minus y equals to 2. Then, of course, the third line will be L3. So our L3 will be 4y minus x, and that is equal to 4y minus x equal to 14. Equals 14. Then the question continues to say hence, find the equation of the line. Find the equation of the line. Find the equation of the line through the point of intersection. Through the point of intersection. Through the point of intersection of L1 and L3. That means the first line and the third line, and parallel to L2. Say, and parallel to L2. So that is the question. So we have to find the coordinates of the vertices of the triangle formed by the lines. You can remember a triangle has three lines. Of course, line 1 is 2x plus 3y equals 5. Line 2 is 3x minus y. 3x minus y equals 2, and line 3 is 4y minus x equals 14. And the question goes further. Hence, find the equation of the line through the point of intersection of L1 and L3, that's line 1 and line 3, and parallel to line 2. Now, let us see the solution. The first thing I'm going to do, I'm going to draw the 3 lines. Let me draw the triangle. This is the triangle. So we have points of intersection. We have here our A, our B, and our C. So it is as simple as that. So this will be line 1, line 2, and line 3. So that is what we are using to illustrate, to explain this. Now you can see that point A is the line, is the intersection of line 1 and line 2. Look at it now. Look at point A now. Look at line 1, line 2. So point A is for line 1 and line 2. Then of course point B is for, look at point B here now. Look at line 1 and line 3 is line 1 and line 3. While point C, you see it, line 2 and line 3. So line 2 and line 3. So point A is the point of intersection of lines 1 and 2. You can see it now. Look at line 1, look at line 2, point A. Then point B is line 1 and line 3. Look at point B. Then point C is line 2 and line 3. So what this simply means, we are going to solve and get the coordinates for these various points A, B, and C. Now for line A, for point A, so we are using lines 1 and 2. Look at line 1 here is 2x plus 3y is equal to 5. Then line 2 is 3x minus y. Of course, this is equal to 2. Now, using same elimination method, we can choose to eliminate x. If we want to eliminate, since x is not having the same coefficient for the two equations, we can now multiply this one by 3, multiply this one by 2, so that we'll now be able to eliminate x. So multiply this one by 3, this will now be 6x plus 9y is equal to 15. Multiply this one by 2, this will be 6x minus 2 times y minus 2y is equal to 2 times 2 will be 4. You see that? So 3 times 2, of course, 6x. 3 times 2x is 6x. 3 times 3y is 9y. 3 times 5 is 15. Using 2 to multiply this. Then now, we can now come and eliminate. Of course, this is plus 6x plus 6x. So it's only a subtraction that will make it to be eliminated. So 6x minus 6x will be 0. 9y minus 2y. Minus becomes plus. 9y plus 2y becomes plus 11y is equal to 15 minus 4 becomes 11. So this implies that y equals 11 all over 11, and that is equal to 1. So our y is 1. Our y is 1. So from here, if our y is 1, we can get from any of the two equations, we can say from, let us use the second equation to get x. 3x minus y is equal to 2. Since our y is 1, we have 3x minus 1, y is 1, is equal to 2. So this will be equal to 3x is equal to 2 plus 1 is equal to 3. X will now be equal to 3 all over 3, and that is equal to 1. So you can see that point A, that simply means that point A having x, y will be equal to 1, 1. So that is how we have been able to get that. So you can see that we have been able to get that. Now, we want to go to get point B. We have gotten point A. Now for point B, now permit me to clean this part. So I will share the board into 2 equal parts. For point B, we are using line 1 and 3. So where is line 1? Line 1 is 2x plus 3y is equal to 5. Then line 3 is, of course, this one will now be minus x plus 4y is equal to 14. So now you have that for point B. So we are now going to eliminate x as usual. So when you come here, you are going to have 2x plus 3y is equal to 5. Then here you have minus x plus 4y is equal to 14. Here, if we are eliminating x, of course you multiply this by 1. Of course you multiply this by 2. So by the time you have that, permit me to clean this too. By the time you have that, you are coming here to have, this will now be 2x, 1 times 2x is 2x plus 1 times 3y plus 3y is equal to 1 times 5 is 5. 2 times minus x minus 2x plus 2 times 4y, 8y is equal to 2 times 14 is 28. Then of course, what sign are we going to do? We are going to add, because this is plus 2x, and of course the second one is minus 2x. So we are going to add to eliminate x. So if you come here, you add now 2x minus plus minus 2x, of course, will be 0. 3y plus 8y, of course, this will be plus 11y. Then 5 plus 28, of course, will give you 33. 33. So from here, this implies that y is equal to 33 all over 11, and that is equal to 3. If our y is 3, permit me to write this here for point C. We are looking at lines 2 and 3. So that I can get the value for y here. So now from since I'm wanting my y to be 3, I can use any of the two equations to get my x. Remember, from here, let me use this one, minus x plus 4y plus 4y. I'm using this one, plus 4y. Y is 3, 4 into 3 is equal to 14. So 4 into 3 is 12. So I will have minus x equals 14 minus 12, and that is equal to 2. So this implies that x is equal to minus 2. So our x is minus 2. So now point B will now be point B, which is now x comma y. Of course, the x coordinate and the y coordinate, it will now be equal to x is minus 2 and y is 3. So that would be for point B. Point B is a point of intersection for lines 1 and 3. Now permit me to go for point C, which is for lines 2 and 3. Permit me to clean these parts. Permit me to clean this part so that we can get for point C. Now for point C, we are using lines 2 and 3. Line 2 is 3x minus y is equal to 2. This is line 2. Then line 3, of course, we write the x first. So you can see y comes first, but it's good we write it in a proper order. So we put your minus x here, which is x. Then, of course, y, 4, we have plus 4y, of course, is equal to 14. Now, again, we want to eliminate x. If you have to eliminate x, of course, you multiply this first equation by 1, because coefficient of x is minus 1. Then you multiply this one by 3. So having that, you are going to have 3x. You are going to have 1 times 3x is 3x minus 1 times y is minus y is equal to 2. 3 times minus x is minus 3x. 3 times 4 is 12 plus 12y is equal to 3 times 14. Of course, multiplying 3 by 14, you are going to have 42. So now what are you going to do to eliminate x? Of course, you add, because this second place of x is having minus 3 as coefficient. So 3x minus 3x, of course, you have 0. Then, of course, minus y plus 12y, of course, that will give you plus 11y. That will give you plus 11y. Then 2 plus 44 plus 42 will give you 44. So this implies that y will be equal to 44 all over 11. Y will be equal to 4. So from any of these two, we can get the value of x. We can get the value of x. So let's use the second one to get the value of x. So, okay. So from here we have minus x plus 4 into, of course, our y is 4. 4 into 4 is equal to 14. So our minus x will be equal to 14 minus 4 times 4 is 16. Going to the other side will be minus 16, and that will be equal to minus 2. Of course, minus will cancel minus. This implies that our x will be equal to 2. So now our point C, having the x coordinate and the y coordinate, will be a value of x is 2 and the value for y is 4. So we have been able to get the first part of the problem solved. We have been able to get that. So you can see that the vertices of the triangle formed by the three lines are, we are going to have it as 1, comma 1, this is for point A. Then for point B is minus 2, comma 3, as required by the, and the third one is 2, comma 4. So these are the vertices of the triangle. That is the points formed by the three lines of that particular triangle A, B, C. So you can see that we have been able to get that. Now, the second part of the problem of the question says, hence, find the equation of the line through the point of intersection of line 1 and line 3 and parallel to line 2. So permit me to clean this part so that we can see how we can achieve the particular solution of that part of the question. Now you can see that from what you have been taught, you can see that from here the point of intersection of line 1 and line 3 is, of course, the point of intersection of line 1 and line 3 is, of course, that is line 1 and line 3 is minus 2 and 3. That's the point of intersection of line 1 and line 3, and that is minus 2 and plus 3. And of course, the gradient of L2, of course, since it is parallel to L2, what is our L2? Our L2 is 3x minus y is equal to 2. So we need to solve for the gradient of L2 since the equation of the line through the point of intersection of L1 and L3 are parallel to L2. So now we have to get the gradient of L2. How do we get the gradient of L2? We have to put it in the format. You remember the normal form. You are going to have here as you are going to have 0 equals, okay, we can have it as 3x minus 2 is equal to y. So of course we can write it as y equals 3x minus 2. Of course, this is the format y equals mx plus c. M is the gradient. Look at it now. Our gradient here, n equals 3. When compared with that particular format. So now, since it is parallel to L2, the equation of the line passing through the points minus 2 and 3 with gradient n equal to 3 will now be, we are going to have, of course, our gradient is n equals y minus y1 all over x minus x1. Now look at the point. The point here is minus 2 and 3. That means our x1 equals minus 2 and our y1 equals to 3. So we are going to put it in this gradient equation. So when you cross multiply, you are going to have your y minus, what is our y1? Our y1 is 3 is equals to m. What is our m? Our m is 3 into x minus, what is our x1 minus 2? Minus 2, you put it in brackets and you close the bracket. So having done this, you are coming to have y minus 3 equals 3 into x plus 2, and that will be equal 3 times x will be 3x plus 3 times 2 is 6. Then this will now be y equals 3x plus 6. Of course, this minus 3 goes to the other side, becomes plus 3. So the equation will now be y equals 3x plus 9. That is the equation of the line through the point of intersection. That is the equation of the line through that point of intersection of L1 and L3 is y equals 3x plus 9. That is what we have been able to get. So you can see that this particular solution has explained the fact that we can get the equation of a line passing through a point and parallel to another line. That is what we have been able to show in this particular example. I hope you are getting it the way it is being taught. You have to watch it again and again to get a better understanding. It is good you understand how these things are solved, because if you follow it up, you will be able to do better with other examples. You study it, and again, for those of you who are watching my video for the first time, if you have not subscribed to my channel, Dr. Chris Esekaiwe, please do that. Share my videos in your social media platform. Click on the notification button so that anytime I upload a new video, you will be among those to get a notification. And for those of you who have subscribed to my channel, I want to say a very big thank you to you. Continue to share the video, and as you do, God will continue to bless you on every side. Like as I said, the essence of this YouTube channel is to share knowledge in key topics in mathematics and statistics across the globe. If you are sharing the videos in your social media platforms, if you are sharing it with your colleagues, if you are sharing it with your friends, it simply means that you are taking part in sharing knowledge across the globe. So we have seen intersecting lines, how to calculate the coordinates of lines that intersect. Now we want to go and take another subtopic in this coordinate geometry part 2. Permit me to clean the board completely so that we can take another subtopic. We are now looking at angles between two lines. We are looking at angles between two lines. Angles between two lines. That's what we shall be looking at. Now, we have looked at intersecting lines. Now we want to see how we can calculate angle between two lines. Angle between two lines. This is what we want to look at now before we go to the area of a triangle. Now, if you have this particular graph, and of course, this is our x-axis, and of course, this is our y-axis, and of course, we have a point that comes like this, and we have another one that comes like this, and of course this angle here is theta, and this angle here is theta 1, and of course this is our point A. This point is point A, and of course this point is point B, and of course there's another angle here. You can call this theta 2, and of course there's another point. You can call this point C. If you have this point, and of course this is line 1 and this is line 2. These are two lines. AC line 1, then BC line 2. Now, the lines L1 and L2 make angles theta 1 and theta 2 respectively with the positive direction of the x-axis. L1, the line L1 and L2, they make the two angles theta 1 and theta 2 in positive direction of the x-axis, in the positive direction of the x-axis. You can see it. This is the positive direction of the x-axis, and of course, if this line cuts across like this will now be our origin. So the lines L1 and L2 make angles theta 1 and theta 2 respectively with positive direction of the x-axis. Now let theta be the acute. Let theta be the acute angle between the lines. This theta, let it be the acute angle between the lines. Now we are going to have the gradients. If theta is the acute angle between the lines, then we are going to have the gradient of line 1. The gradient of line 1 will be tan theta 1, and the gradient of line 2, which is M2, will be tan theta 2. That is what it means. So this, of course, remember n has to do with gradient, and when you talk about the straight line, is given as mx plus c. Don't forget where our n here is our gradient, while our c is the intercept. So you need to understand that. So now, if m1 is the gradient of the first line and theta be the acute angle between the two lines, so our m1 will be theta 1, tan theta 1, and our m2 will be tan theta 2. Remember, tan is opposite over adjacent. Opposite over what? Adjacent. So you should have that. Now, this simply means that our theta 2, of course, our theta 2 will now be equal to theta. Our theta 2 will be equal to theta plus theta 1. You see it? This theta 2 here. Now, why is it like that? Because exterior angles of triangle ABC, because they are what? It is the exterior angle of triangle. Exterior angle of triangle ABC. So this is, you can see now, look at triangle ABC. This theta 2 is exterior. So when you add theta to theta 1, you will get theta 2. That is what that simply means. So it means that by implication, it simply means that our, if we are to continue from here, it means that our theta alone will be equal to theta 2 minus theta 1. So this implies that tan theta will be equal to tan into theta 2, tan into theta 2 minus theta 1. That is what it means. So if you make theta the structure of the formula, it will be theta 2 minus theta 1. And we know the compound angle expansion of tan into theta 2 minus theta 1. Of course, we have the compound angle expansion of that. So if we are to expand this using compound angle in trigonometry, we are going to have your tan theta will now be equal to tan theta 2 minus tan theta 1. I'm talking about compound angle expansion. That will now be all over 1 plus tan theta 2 tan theta 1. That is the compound angle expansion of tan into theta 2 minus theta 1. For those of you who have done trigonometry to the point of compound angles, we have for sine, we have for cosine, we also have for tangent. I think I will bring up that topic in one of my videos in weeks to come, talking about trigonometry, compound angles in trigonometry. So proceeding in this way, of course, you can now see that our M1 is tan theta 1, our M2 is tan theta 2. So bringing this, we now have our tan theta will be equal to, what is our tan theta 2? M2 minus our tan theta 1 is M1 all over 1 plus tan theta 2 is M2, tan theta 1 is M1. So this will now be the formula for calculating the angle between two lines. For calculating the angle between two lines. So permit me, so you can see we have been able to get that. So permit me to clean this part so that I can make some further explanation in this particular subtopic. I want to make some further explanation in this subtopic. Now, as we progress, you can see that in a situation where if the two lines are parallel, now let's take a look. If the two lines are parallel, that means our theta is equal to 0 degrees. Two parallel lines don't meet. Parallel lines don't meet. So if the lines are like this, of course, they cannot form any angle together. So the angle formed by parallel line, of course, is 0 degrees. So it simply means that the lines don't meet, so it is 0 degree. Theta will be 0 degree when the two lines don't meet. Now, of course, doing this, you will know that now if we want to calculate the angle using that formula, then of course here we are going to have tan 0 degree, of course, which is equal to 0. It will be equal to mu 2 minus mu 1 all over 1 plus m2 m1, and of course is 0. Tan 0 is 0. When you now cross multiply, you are going to have the m2 minus m1 equal to 0, because if you cross multiply this by 0, that means you are going to get 0. So that means our m2 will be equal to m1. What does this mean? It means that if the two lines are parallel, the gradient formed by the gradient of the two lines are the same. That is what it means. It means that the gradient of the two lines are the same. If the two lines are equal, it means that the gradient of the two lines are the same. That is the meaning of that. So you can see, if the two lines are parallel, they will not be able to form any angle. They have 0 degree. Then now, if you put this in this formula for calculating the angle, you now see that for parallel lines, if lines 1 and 2 are parallel, it means the two lines will have the same gradient. That means this implies that the lines have the same gradient. That's what it means. Now, another point, if the two lines are perpendicular, that means our theta will be equal to 90 degrees. Perpendicular means, this is what we mean by perpendicular. The first line is this, and the other one is like adjacent to the other one. So it simply means that the angle that will be formed by the two lines will be 90 degrees. So now if you come here, our tan 90 degrees is equal to infinity. So you put it here, you are going to have tan 90 degrees equals m2 minus m1 all over 1 plus m2 m1, and that is equal to infinity. So infinity simply means 1 all over 0. So cross multiplying, this multiplied by 0, this multiplied by 1. So you are going to have 1 plus m2 m1 is equal to, of course, 0 times this is equal to 0. So that is what you are going to have. So, of course, continuing in this format, this simply means that m2 m1 will be equal to minus 1. So this simply means that, hence, if the two lines are perpendicular, the product of their gradient is minus 1. If the two lines are perpendicular, the product of their gradient is minus 1. That is what it means. If the two lines are perpendicular, of course, the angle that will be formed by the two lines is 90 degrees, and of course, tan 90 degrees is infinity, and infinity is 1 all over 0. So when you have put it here, 0 times m2 minus m1 will be 0. You put it 0, and then 1 times 1 plus m2 m1 will be 1 plus that. Then you, of course, this one will go to the other side. Then the product of the two gradients, which is m1 is the gradient of the first line, m2 is the gradient of the second line. So when the two lines are perpendicular, that means they are forming 90 degrees, then of course expect the product of the two gradients of the two lines to be equal to minus 1. Now we are going further to get to solve a particular problem. By the time we solve this problem, you will see how this is done. So permit me to clean this part. I just use this to explain and get the formula for finding the angle between two lines. This is as simple as what you are seeing on the board. Now let us go find the acute angle between the pair of lines. Example, find the acute angle between the pair of lines. Look at the first line here is y is equal to 2x plus 6, and the second line is y is equal to 3x minus 2. So you have to find the angle between these two lines. Acute angle is less than 90 degrees, is greater than or equal to 0, but less than or equal to 90 degrees. That's what an acute angle is. So now all we just need to do, this is already, of course, the straight line format is y equals mx plus c, so that you can get. So now this is the first line. You can call this line 1, call this line 2. Of course, what will now be the gradient here? The gradient of the first line, you call it m1, and that will be equal to 2. Then the gradient of the second line, which is m2, that will be equal to 3, following this format. So it is as simple as ABC. The angle between the line is theta. So the angle between the two lines, the angle is theta. So you can come here and use the particular formula that we have. Tan theta equals m2 minus m1 all over 1 plus m2 m1. So what is our m2? Our m2 is 3 minus what is our m1 is 1. No, our m1 is 2. Then all over 1 plus 3 times 2. That is m2 and m1. So that will be equal to 1 all over 3 times 2, 6. 6 plus 1 is 7. So our theta will be equal to arctan. I hope you have done trigonometry up to this level. This is tan theta. when it's going to the other side, become arctan of 1/7. So for those of you who have your calculator, all you just need to do is to press the second function of tan, and you're going to get 8.13 degrees. So the angle formed between the formed by the two lines is 8.13 degree, and so on and so forth. So you can see that doing this, it is as easy as ABCD. This is as simple as we can see. Now let us go ahead and see how we can, that is how to calculate the angle between two lines. So I will go straight to another subtopic, the area of a triangle in terms of the coordinates of its vertices. So let's go. I hope you have gotten this. Now we are looking at another subtopic, the area of a triangle in terms of the coordinates of its vertices. The area of a triangle. So you can see that this particular topic is becoming more interesting. If you have not subscribed, please subscribe to this channel and share my videos in your social media platform. So the area of a triangle in terms of its the coordinates of its vertices. So we are using the coordinates of the vertices of the triangle to calculate the area. Now you should understand that a triangle has 3 lines, and of course it's expected to have 3 vertices. The vertices are likened to be the point. So the area of triangle, ABC with vertices. Look at the vertices. Of course, A will be x1, y1, B will be x2, y2, and C will be x3, y3. The area will be given as 1/2 into x1, y2 minus x2, y1 plus x2, y3 minus x3, y2 plus x3, y1 minus x1, y3. So this is the formula for calculating the area of triangle ABC having the 3 vertices, A into x1, y1, B into x2, y2, and C into x3, y3. So we can calculate the area of the triangle when the 3 vertices formed by the triangle, when the coordinates are known. When these coordinates are known, then it is very easy to carry out the calculation. So now let's go quickly to an example. We don't talk much. Find the area of the triangle whose vertices are. Find the area of the triangle whose vertices are. Look at the vertices. We have 4,7, the second one is 0,2, and the third vertex is -3, -3,0. So you can see this is Also very easy. Now, one thing you must understand, we must take the absolute value. If you calculate the area of the triangle and you have a negative value, you must take the absolute value of that negative value, because no area is negative. The area of a quantity of a particular shape is measured in square units and it is not negative. So if you calculate and you get a negative value, definitely you take the absolute value of that. Now, see what we are going to do. Solution is simple. From here, our x1 is equal to 4, our y1 is equal to 7, our x2 is equal to 0, our y2 is equal to 2, then our x3 is equal to minus 3, and our y3 is equal to 0. It's good to write this out, and when you write it out, it will be easier to fix them into the particular formula that is given above. So area of the triangle will be equal to, look at it, we have 1 all over 2 into, this is x1. What is our x1? Our x1 is 4 times y2. What is our y2? Our y2 is 2. Of course, the minus sign is there. Then, of course, what is our x2? Our x2 is 0. 0 times, what is our y1? Our y1 is 7. Then you put your plus sign. What is our x2? Our x2 is 0. What is our y3? Our y3 is 0. Then of course minus, what is our x3? Our x3 is minus 3. Then what is our y2? Our y2 is 2. Then of course, then plus, what is our x3? Our x3 is minus 3. Times, what is our y1? Our y1 is 7. Then of course minus, what is our x1? Our x1 is 4. Then what is our y3? Our y3 is 0. Then of course you put in greater bracket. Then you now have 1 all over 2 into, you have all this. If you have this here now, this will be 8. Of course this will be 0. Look at this. This is 4 times 2 is 8. 0 times 7 is 0. So it's not needed. 0 times 0. Then this is 3. Minus 3 times 2 is minus 6 times minus. Of course, it will be plus 6. Then you come here. Minus 3 times 7 is minus 21. Of course, this will be 0. Minus 21. So you are going to have minus 7 over 2. This 8 plus this is 14. 14 minus 21, this will now be minus 7 all over 2. And of course, you are going to take the absolute value, that will be 3 all over 2. So this will be 3 all over 2 square. So now, the area is always in square units. Area equals 3½ square units. So that is what the area of that triangle is. That is what the area of that particular triangle is. Now, permit me, I want to take the area of a quadrilateral. I hope you have taken the formula. You can see how we have been able to calculate the area of a quadrilateral, of a triangle. Now, I want to tell us how we can calculate the area of a quadrilateral. Then from there, we look at collinear points. We call it a day. Permit me to clean this part quickly. So that's the formula for calculating the area of a triangle using the coordinates of the vertices formed by that particular triangle. Now we are looking at area of a quadrilateral using, of course, the coordinates of its vertices. Now, one thing you need to note is that the area of a quadrilateral can be obtained using the coordinates of its vertices by dividing, please take note of this, by dividing the quadrilateral into two triangles and obtained the area that is made up of n minus 2 non-intersecting triangles. I give an example. If I have a quadrilateral that has maybe 6 sides, A, B, C, D, E, F, it's going to form 6 sides. It means that quadrilateral will have n minus 2 non-intersecting triangles. What you need to do is to get the area of each. Look at it now. We are going to get n. What is our n here? Of course, we have 1, 2, 3, 4, 5, 6. So a quadrilateral is an n-sided shape. So this one is a 6-sided shape. So we are going to have 6 minus 2. That is equal to 4 triangles, 4 non-intersecting triangles. How am I going to form these triangles from here? Look at it. We are going to get triangle A, B, C. C stops here. You are going to get triangle A, C, D. This one stops at D. The next one will be triangle A, D, E. Then the next one will be triangle A, E, F. You see the way I wrote it? If I have maybe 4 sided quadrilateral, maybe A, B, C, D. So I'm going to have 4 minus 2, that is equal to 2 non-intersecting triangles. How do I get this? The first triangle will be triangle A, B, C. Look at where the first one ends at C. So the next one will be A. Each of them will start from the first point. The next one will be A. Of course, since this one ends with C, it will be triangle ACD. So these are the 2 non-intersecting triangles I will get from this quadrilateral that has 4 sides. If it's a 6-sided quadrilateral, you can see the triangles I've been able to form out of it. So you are going to have n minus 2 non-intersecting triangles. After you have gotten these triangles, all you just need to do is to get the area of this triangle, get the area of this triangle. Remember, no area of a triangle is negative value. So when you get the area of this first triangle, you take the absolute value. When you get the area of the second triangle, you take its absolute value, then you add the two together, you will get the area of the quadrilateral A, B, C, D. Just like this quadrilateral with 6 sides, A, B, C, D, E, F. It has 4 non-intersecting triangles with A, B, C, A, C, D, A, D, E, A, E, F. You will find the area of this triangle A, B, C, find the area of this triangle A, C, D, find the area of this triangle A, D, E, find the area of this triangle A, E, F. You add the 4 areas together, you will get the area of quadrilateral A, B, C, D, E, F. So let me take an example. A 4-sided quadrilateral now. The 4-sided quadrilateral can be a square, it can be a rhombus, it can be a rectangle, just a 4-sided quadrilateral. Say, find the area of the quadrilateral. Example now. Find the area of the quadrilateral A, B, C, D, having the vertices, having the following given by, you see, it is as simple as ABCD, that means the coordinates of the vertices The first one is 1, 1. Of course, the second one is 5, 4. Then the third one is 4, minus 1. And of course, the fourth one is minus 3, minus 12. So you can see now it's a four-sided figure, a four-sided quadrilateral. Now you are going to have n minus 2 non-intersecting triangles. Now how do I get it? The quadrilateral is ABCD, so I'm going to have, of course, the first one will be ABC. Then of course the starting point will always be the first point. The next one will be A. Where does this first triangle end? C. AC. Then the last one D. So these are the two triangles, two non-intersecting triangles that this particular quadrilateral will form. So we are going to calculate the area of triangle ABC, and we're also going to calculate the area of triangle ACD. Then we add the two together. Now, area of triangle ABC, let's go. Area of triangle ABC. Remember, let me write the area of the triangle out. The area of the triangle area is 1/2 into, permit me to write it out. You have x1, y1 minus, x1, y2 minus x2, y1. Then, of course, plus, you have x1, y2 minus x2, y1 plus x2, y3, x2, y3 minus x3, y2, of course, plus, of course, the third one is x3, y1 minus x1, y3. So this formula is the formula for calculating the area of a triangle. Now, if you are calculating the area of triangle ABC, this will be given as 1/2. Remember, what are the 3 points that we are going to use? We are going to use, this is A, this is B, this is C, and this is D. So, but we are using ABC here. So, if we are using ABC here, this simply means our x1 is equal to 1, our y1 is equal to 1, our x2 is equal to 5, our y2 is equal to 4, our x3 is equal to 4, our y3 is equal to minus 1. So that's what we are going to use here now. We are using this, this, and this. So if we have that, now what is our x1? If we come here, our x1 is 1. 1 times, what is our y2? Our y2 is 4. Then of course, minus, what is our x2? Our x2 is 5 times, what is our y1? Our y1 is 1. Then of course you put your plus. Then what is our x2? Let me continue here. Our x2 is 5 times, what is our y3? Our y3 is minus 1. Of course, then minus, what is our x3? Our x3 is 4 times, what is our y2? Our y2 is 4. Of course, then plus, what is our x3? Our x3 is 4. And what is our y1? Our y1 is 1. Then minus, what is our x1? Our x1 is 1 times, what is our y3? Our y3 is minus 1. Then you put a bigger bracket. So triangle area of triangle ABC will now be equal to, you put your 1/2 into, you begin to take the values that are therein. Of course, let's look at it. 1 times 4 minus 5 times 1 plus 5 times minus 1 minus 4 times 4 plus 4 times 1 minus 1 times minus 1. So carrying out arithmetic, you are going to have minus 17. Let's take it first. This is 4 times 1 is 4. 5 times 1 is 5, so to be 4 minus 5 should be minus 1, of course, plus, then you come here, 5 times minus 1 is minus 5, minus 5 minus 20, minus 5 minus 16, that is minus 5 minus 16 minus 21, of course, then you come here, 4 times 1 is 4, okay, so minus 1 times 1 is minus 1, so 4 plus 1, of course, plus 5. So when you have that, you are going to have minus 22 plus 5, of course, minus 17. So this will be equal to minus 17 all over 2. So, of course, since we are taking the absolute value, the area of triangle ABC will be equal to, to 17 all over 2 square units. That is what we are going to have for the area of triangle ABC. Now we want to calculate the area of triangle ACD. Area of triangle ACD, we are going to calculate the area of triangle ACD. Now, for area of triangle ACD, permit me to clean this part of the board. Area of triangle ACD, permit me to clean this part of the board for area of triangle ACD. Now, if we want to calculate the area of triangle, of course, this is A. So area of triangle ACD. Now we are using this. We are using ACD. So here now our x1 will be 1, our y1 will be 1. Of course, we are using this, and we are using this. So our x2 will be 4, our y2 will be minus 1, which is this. Then our x3 will be minus 3, and our y3 will be minus 12. That is what we are going to use. So having this, so our area of triangle ACD will be equal to 1 all over 2 into, you now have all that. You now have brackets. Of course, what is our x1? Our x1 is 1. So you have 1 times our y2 is minus 1. Of course. Then of course minus, what is our x2? Is 4 times y1. Our y1 is 1. Then of course you put your plus sign plus, what is our x2? Our x2 is 4 times, what is our y3? Minus 12. Then of course you put your minus, what is our x3? Our x3 is minus 3 times, what is our y2? Our y2 is minus 1. Then of course you put your plus, what is our x3? Our x3 is minus 3 times, what is our y1? Our y1 is 1. Then of course minus, what is our x1? Our x1 is 1 times, what is our y3? Our y3 is minus 12. You cover the bracket and you cover the bigger bracket. So the area will be 1 all over 2 into, by the time you carry out those arithmetic, you are going to have minus 47 over 2. You are going to have minus 47. So that will be equal to 23 minus, of course, it will be, you take the absolute value of it. So it's going to be 23.5 square units. That's what you are going to have as the area of that. So now, the area of quadrilateral, let's come here and continue. Area of quadrilateral A, B, C, D will be equal to area of triangle A, B, C plus area of triangle ACD, and that will be equal to the area of triangle ABC was 8.5, so this will be 8.5 plus 23.5, of course in square unit. So the area in total, the area will now be equal to 8.5 plus that, it will now be 32 square units. So that will now be the area of quadrilateral ABCD. So you can see if the triangles that are formed are 3 triangles, you get the area of the 3 triangles and add them together. If you form 4 triangles, 4 non-intersecting triangles, you get the area of the 4 non-intersecting triangles and add them together, then you get the area of the quadrilateral. Now let's go to the last part of the class, which is collinear points. Permit me to clean all this. We are looking at the last part of today's class, collinear points. When are 3 points said to be collinear? What do we mean by collinear points? When are 3 points said to be collinear? Collinear points. When are 3 points said to be collinear? When are 3 points said to be collinear? Now look at it, collinear points. Collinear points. So, when we talk about collinear points, 3 points, A, B, C, 3 points, A, B, C are said to be collinear if they lie on the same straight line. 3 points are said to be collinear if they lie on the same straight line. What does this mean? It means that the area of the triangle formed by the 3 lines is 0. That means the area of triangle ABC will be equal to 0. That is that. Then another condition for collinearity is if 3 points are collinear, then the gradient of the line as determined by any 2 of the points is the same. The gradient of the line as determined by any 2 of the points is the same. That simply means that also, I said if 3 points are collinear, then the gradient of the line as determined by any 2 of the points is the same. So if the points A, B, C are collinear, then the gradient of the line will now be y2 minus y1 all over x2 minus x1 will be equal to y3 minus y1 all over x3 minus x1. That is what it means. That is what it simply means. So this gives the necessary condition for 3 points to be collinear. Now, let us take an example. If we have an example, show that the 3 points are collinear. Show that the 3 points A into 1, 5, B into A is into 1,5, the B into minus 3,9, then you cover, and C into, which is the third point, minus 2,8, minus 2,8. So that these are collinear. So that they are collinear. What we really need to do is to show that the area of the triangle formed by the point is 0. So here now, solution, our x1 is equal to 1, our y1 is equal to 5, our x2 is equal to minus 3, then our y2 is equal to 9 from here, our x3 is equal to minus 2, and our y3 is equal to 8 from this point given. So area of triangle ABC will now be equal to, it is as simple as that. You are going to have 1 all over 2 into, of course, bracket open 1 times 9, minus bracket open minus 3 times 5, you close it, then plus bracket open minus 3 times 8, minus 3 times 8, then minus bracket open minus 2 times 9, then you cover the bracket, then of course plus minus 2 times 5, then you cover that, then of course minus bracket 1 times 8. So when you have this, you are going to have it as 1 all over 2 into 42 minus 42, and that will be equal to 0. So now say hence A, B, C are collinear points. Why? The area of the triangle is 0. So the area of the triangle formed by these 3 points is equal to 0. So we take another example on collinear points and we call it a day for this particular class. So please let me take a last example, but let me to clean this part on still on collinear points. Still on collinear points, you can see that the area of the triangle is 0. So the 3 points are collinear. So the 3 points are collinear. Now, the last example for today's class is if the point A into 5,6, P into X, Y, and B into 2,3 are collinear, show that x minus y plus 1, x minus y plus 1 equals to 0. So now let's look at the solution. Now we are using the gradient. Remember, the second point for collinearity of 3 points is that if the 3 points are collinear, then the gradient of the line as determined by any 2 of the points is the same. So the gradient of the line as determined by any 2 of the points is the same. So it is as simple as ABCD. So we are going to use this. That means our y2 minus y1 all over x2 minus x1 equals y3 minus y1 all over x3 minus x1. That is what that particular point says. So now, having gotten this, we are coming to have, look at the point there. You have your This is your first point, of course, the second point, and the third point. Here now, we are going to have our x1. Our x1 is equal to 5. Our y1 is equal to 6. Our x2 is equal to x here. Our y2 equals to y here. And our x3 is equal to 2. And our y3 is equal to 3. From this particular point, all we just need to do is to plug them into this. So our y2, of course, our y2 is y. Look at it, our y2 is y, so we are going to have y minus, what is our y1? Our y1 is 6 all over. Let me write the 6 clearly. Then our x2 is x all over. What is our x1? Our x1 is 5, that's equal to, what is our y3? Our y3 is 3 minus, what is our y1? Our y1 is 6 all over. What is our x3? Our x3 is 2 minus, what is our x1? Our x1 is 5. So this will be 3 minus 6 is minus 3 all over. 2 minus 5 is also minus 3. So we are going to have y minus 6 all over x minus 5 is equal to 1 minus 3 over minus 3 is 1. So by the time you cross multiply, you are going to have, by the time you cross multiply, this implies that our x minus 5 into 1 cross multiply is equal to y minus 6. So here you are going to have x, 1 by x is x, minus 1 times 5 is 5, is now equal to y minus 6. So, of course, taking the like terms, you're going to have, this implies that you're going to have x minus y, this comes to the other side, of course, minus 5, of course, this minus 6 goes to the other side, it comes plus 6 equals to 0. So, therefore, we have x minus y minus 5 plus 6 is plus 1, and that is equal to 0 as required by the question. So, beloved, we have come to the end of this class today. We have been able to look at coordinate geometry part 2. We shall be coming up with a third video on coordinate geometry. This is not the last part of coordinate geometry. We also have another part which is where I will take as the last part, which is coordinate geometry part 3. We shall be looking at the area of a circle, the area of a parabola, the area of a hyperbola, the area of ellipse. I will be solving some problems using them. Beloved, I hope you have learned something from the class today. We looked at intersecting lines. We looked at area of a triangle. We looked at area of a quadrilateral. We also looked at the collinear point, and we also looked at the angle between two lines. I hope you have learned from this class today. Please share my videos in your social media platform. For those of you who have not subscribed, please subscribe. And if peradventure you are an AI firm, you deal on you train AI models, why not you can call me to be part of your team of mathematicians that train your AI model. I've been privileged to work with 2 firms in US, AI firms in US, where I assisted in training AI models. I created prompts to stomp the model, and I also created golden responses and rubrics, and also chain of thoughts for the training of these models. I will be looking forward to hearing from you. My contact is also in the description part of my channel. You will also see my contact at the beginning of each of my video. Thank you for waiting patiently, for watching this video to the end. God bless you. Enjoy the rest of the day. Bye.